The Secret Life of Albert Einstein.
Albert Einstein, March 14, 1879 to April 18, 1955, was a renowned theoretical physicist known for his groundbreaking contributions to the field of physics.
Here is an overview of his life. Albert Einstein's early life was marked by several key events and experiences that contributed to his development as a brilliant physicist. Here are some important aspects of his early years.
Birth and family. Albert Einstein was born on March 14, 1879, in the city of Ulm, located in the Kingdom of Württemberg in what is now Germany.
His parents were Hermann Einstein and Pauline Koch. He had one younger sister, Maya. Childhood and schooling. Einstein's early childhood was marked by curiosity and a love for mathematics.
He began playing the violin at a young age, a passion that would stay with him throughout his life.
He attended primary and secondary schools in Munich, Germany.
Family relocation. In 1894, when Einstein was 15, his family moved to Milan, Italy, where his father had taken a job. Albert remained in Munich to complete his education but felt somewhat isolated during this period. Swiss education. In 1896, Einstein joined his family in Milan but soon left for Switzerland to attend the Swiss Federal Polytechnic, ETH Zurich, in Zurich. He had to take an entrance exam to get in. He graduated in 1900 with a diploma to teach physics and mathematics.
Marriage and family. In 1903, Einstein married Mileva Marek, a fellow student from ETH Zurich.
They had two sons, Hans Albert and Eduard, but their marriage faced difficulties and eventually ended in divorce in 1919.
Einstein later married his cousin Elsa Lowenthal. Early career. After graduating, Einstein struggled to secure an academic position and worked briefly as a patent examiner at the Swiss Patent Office in Bern.
It was during this time that he developed many of his groundbreaking ideas in physics, leading to the publication of his Annus Mirabilis Papers in 1905. Special theory of relativity. In 1905, Einstein published his theory of special relativity, which challenged conventional ideas about space and time.
This theory introduced concepts like time dilation and the equivalence of mass and energy, E equals mc squared. Academic appointments. Einstein eventually obtained academic positions, including a professorship in Prague and a position at the Kaiser Wilhelm Institute for Physics in Berlin. These positions allowed him to focus on his research. Einstein's early life was marked by intellectual curiosity, a self-driven pursuit of knowledge, and a deep passion for physics and mathematics.
These qualities played a significant role in his later groundbreaking work in theoretical physics and the development of his famous theories of relativity.
Albert Einstein's education played a crucial role in his development as a physicist. Here's an overview of his educational journey. Early education. Einstein's early education began in Munich, Germany, where he attended primary and secondary schools. His parents, recognizing his intellectual potential, encouraged his interest in science and mathematics.
Moved to Milan. In 1894, when Einstein was 15, his family moved to Milan, Italy, where his father had secured a job.
Albert remained in Munich to complete his education, living with relatives and friends.
Entrance to Swiss Federal Polytechnic. In 1895, Einstein attempted to gain admission to the Swiss Federal Polytechnic, ETH Zurich, a prestigious technical university. However, he did not pass the entrance exam in the first attempt, which led to a gap year during which he continued his education at a school in Aarau, Switzerland. He eventually passed the entrance exam in 1896 and entered the Swiss Federal Polytechnic. Studies at ETH Zurich. At the Swiss Federal Polytechnic, Einstein pursued a four-year program in mathematics and physics. He graduated in 1900 with a diploma to teach physics and mathematics. During his time at ETH Zurich, he developed a strong foundation in these subjects, which laid the groundwork for his future work in theoretical physics. Doctorate. After completing his studies at ETH Zurich, Einstein continued his academic journey by working on his doctoral thesis. In 1905, he completed his doctoral dissertation, A New Determination of Molecular Dimensions.
This marked the beginning of his career in academia.
It's worth noting that while Einstein was an exceptional student, he often clashed with the educational system and its rigid structure. He valued independent thinking and was known to question authority and convention, which would later be reflected in his groundbreaking scientific theories. Einstein's education, coupled with his natural curiosity and intellectual abilities, provided him with the foundation necessary to make significant contributions to the field of physics. His later achievements, such as the theory of special relativity and the theory of general relativity, would reshape our understanding of the universe. The Annus Mirabilis Papers refers to 4 groundbreaking scientific papers published by Albert Einstein in the year 1905. These papers, written during his time working as a patent examiner in the Swiss Patent Office in Bern, Switzerland, had a profound impact on the field of physics and significantly influenced the development of modern physics. The term Annus Mirabilis is Latin for miraculous year or wonderful year and is used to describe the remarkable productivity and insights Einstein achieved during that year. The 4 papers are: On a heuristic viewpoint concerning the production and transformation of light, March 1905. In this paper, Einstein introduced the concept of quanta of light, which we now call photons. He explained the photoelectric effect by proposing that light is composed of discrete packets of energy, rather than being a continuous wave. This work laid the foundation for quantum mechanics. On the motion of small particles suspended in liquids at rest required by the molecular kinetic theory of heat, April 1905. In this paper, Einstein provided a theoretical explanation for the random motion of particles suspended in a fluid, now known as Brownian motion. His explanation demonstrated the existence of atoms and molecules and provided strong evidence for their existence. On the electrodynamics of moving bodies, June 1905. This is the paper where Einstein presented his theory of special relativity. It introduced the famous equation E equals mc squared and radically transformed our understanding of space and time. Among its many profound ideas, it proposed that the laws of physics are the same for all observers in uniform motion. Does the inertia of a body depend upon its energy content? September 1905. In this paper, Einstein expanded upon his special theory of relativity and introduced the concept of mass-energy equivalence. He famously derived the equation E equals mc squared, which states that energy and mass are interchangeable, and a small amount of mass can be converted into a large amount of energy. The publication of these 4 papers in a single year marked a turning point in the history of physics and established Albert Einstein as a leading figure in the scientific community. These papers contributed significantly to the development of quantum theory, the theory of relativity, and our understanding of the fundamental nature of the universe. Albert Einstein's academic career was marked by his work as a physicist, researcher, and professor at various institutions. Here is an overview of his academic career. Early career: After completing his education at the Swiss Federal Polytechnic in Zurich, Einstein initially had difficulty finding an academic position. He worked briefly as a patent examiner at the Swiss Patent Office in Bern from 1902 to 1909, where he evaluated patent applications related to electromagnetic devices. This position allowed him the time and mental space to work on his own scientific ideas, leading to the publication of his groundbreaking papers in 1905.
Academic appointments. In 1908, Einstein received his first academic appointment as a lecturer at the University of Bern.
In 1909, he became an associate professor at the University of Zurich. During this time, his scientific reputation continued to grow, and he published several important papers. Prague and Berlin. In 1911, Einstein was appointed to a full professorship at the German University in Prague, now Charles University.
He later returned to Germany in 1914 to accept a position at the Kaiser Wilhelm Institute for Physics in Berlin. This marked a significant advancement in his academic career. General theory of relativity. While in Berlin, Einstein developed and published his theory of general relativity, which revolutionized our understanding of gravity. This theory predicted the bending of light by gravity and was confirmed during the 1919 solar eclipse, catapulting Einstein to international fame.
Nobel Prize. Despite his significant contributions to physics, Einstein was awarded the Nobel Prize in Physics in 1921 for his work on the photoelectric effect, not for his theories of relativity. The photoelectric effect is described in one of his 1,905 papers. Later academic positions. Einstein held various academic positions throughout his career, including a professorship at the University of Leiden in the Netherlands, a visiting professorship at the California Institute of Technology, Caltech, and a position at the Institute for Advanced Study in Princeton, New Jersey.
Emigration to the United States. With the rise of the Nazi regime in Germany, Einstein emigrated to the United States in 1933. He accepted a position at the Institute for Advanced Study in Princeton, where he remained until his retirement. Academic legacy. Even after his retirement, Einstein continued to be a prominent figure in the academic world, mentoring students and engaging in scientific discussions. His work laid the foundation for further research in theoretical physics and cosmology. Albert Einstein's academic career was characterized by his groundbreaking contributions to physics, including the theories of special and general relativity, as well as his commitment to scientific inquiry and the advancement of human knowledge. His work continues to influence and inspire scientists to this day. The general theory of relativity, formulated by Albert Einstein and published in 1915, is one of the two major theories of gravitation in modern physics, the other being Newton's theory of gravitation. The general theory of relativity is a fundamental theory that describes how gravity works in our universe and has had a profound impact on our understanding of space, time, and the cosmos. Here are the key principles and concepts of the theory. Equivalence principle. The theory is built on the principle of equivalence, which suggests that gravitational and inertial forces are indistinguishable. In other words, a person inside a sealed, windowless room cannot tell whether the room is in freefall under the influence of gravity or is accelerating due to some other force. This concept led to the understanding that gravity is the result of the curvature of spacetime. Curved spacetime. According to general relativity, massive objects, like stars and planets, cause spacetime to curve around them. In the presence of mass or energy, spacetime is distorted, and objects follow paths, or geodesics, determined by this curvature. The larger the mass, the greater the curvature of spacetime around it. Geodesics. Objects in freefall move along geodesics, which are the natural, straightest paths through curved spacetime. These paths are what we perceive as the trajectories of objects under the influence of gravity. Einstein's field equations. The mathematical framework of general relativity is encapsulated in Einstein's field equations, a set of 10 interconnected equations that describe the relationship between the curvature of spacetime and the distribution of matter and energy in the universe. Bending of light. General relativity predicts that the path of light is bent when it passes near massive objects. This prediction was confirmed during a solar eclipse in 1919 when the stars near the Sun appeared to be in slightly different positions than they should be due to the Sun's gravitational field. Gravitational time dilation. The theory also predicts that time flows differently in regions of different gravitational potential. In strong gravitational fields, time passes more slowly than in weaker fields. This phenomenon has been observed through experiments with highly accurate atomic clocks. Expanding universe. General relativity was later incorporated into the expanding universe models of cosmology, leading to the understanding that the universe is not static but is expanding. This concept eventually gave rise to the Big Bang theory of the origin of the universe. Black holes. General relativity predicts the existence of black holes, regions of spacetime where the gravitational field is so strong that nothing, not even light, can escape from within the event horizon. The general theory of relativity has been confirmed by numerous experiments and observations and is considered one of the most successful and accurate scientific theories in history. It has had a profound impact on our understanding of the fundamental forces of the universe and has opened the door to new insights into the nature of spacetime, gravity, and the cosmos. Albert Einstein was awarded the Nobel Prize in Physics in 1921, but it was not for his famous theory of relativity, as one might expect. Instead, he received the Nobel Prize for his work on the photoelectric effect.
The Nobel Prize in Physics that Einstein received was specifically for the following contributions.
Photoelectric effect. In 1905, in one of his Annus Mirabilis Papers, Einstein proposed a groundbreaking explanation of the photoelectric effect.
The photoelectric effect is the emission of electrons from a material when it is exposed to light. In his theory, Einstein suggested that light is composed of discrete packets of energy called quanta or photons. He argued that the energy of a photon is directly proportional to its frequency. This concept was revolutionary and provided critical evidence for the emerging theory of quantum mechanics.
Einstein's work on the photoelectric effect had important applications in the development of quantum theory.
While Einstein's theory of relativity is arguably his most famous and groundbreaking work, it did not receive the Nobel Prize, primarily because the theory was not fully accepted and confirmed by experimental evidence at the time of the award. Additionally, the Nobel Committee's decision was influenced by factors like scientific politics and disagreements within the scientific community about the theory of relativity. Nonetheless, the Nobel Prize for the photoelectric effect recognized the significance of Einstein's work in advancing our understanding of the behavior of light and matter and the development of quantum mechanics. It remains one of the most iconic and well-deserved Nobel Prizes in the history of physics. Albert Einstein's emigration refers to his decision to leave his home country of Germany and move to the United States due to the political and social circumstances in Europe during the early 1930s.
Here's an overview of Einstein's emigration. Rise of the Nazi regime. Albert Einstein, who was of Jewish heritage, was living in Berlin when Adolf Hitler and the Nazi Party came to power in Germany in 1933.
The Nazi regime was openly hostile to Jews, and Einstein's theories of relativity were denounced as Jewish physics.
Anti-Semitic persecution. As a prominent intellectual and Jew, Einstein became a target of anti-Semitic propaganda and persecution.
He received numerous threats, and the Nazi government's policies and rhetoric were a growing concern for his safety and freedom. Offer from the Institute for Advanced Study. In 1932, before Hitler came to power, Einstein had already received an offer from the Institute for Advanced Study, IAS, in Princeton, New Jersey, to join their faculty as a visiting professor.
This offer provided him with a safe and prestigious academic haven in the United States.
Emigration to the United States. In 1933, Einstein and his wife, Elsa, left Germany for the United States, with the intention of taking up his position at the IAS in Princeton. He accepted a post as a resident scholar, which allowed him to work on his research and engage with other leading scientists in a politically stable environment.
American citizenship. Einstein emigrated to the United States and ultimately became a naturalized American citizen in 1940.
He spent the rest of his career in the United States, working at the IAS and later at Princeton University. Einstein's emigration to the United States allowed him to continue his scientific work, free from the political turmoil and anti-Semitic persecution in Europe. During his time in the United States, he continued to make significant contributions to physics and also became an advocate for civil rights, nuclear disarmament, and various humanitarian causes.
His emigration played a crucial role in ensuring his safety and enabling him to continue his scientific endeavors in a more stable environment.
Albert Einstein played a significant, albeit indirect, role in the development of the atomic bomb during World War II.
Here is an overview of his involvement in the context of World War II and the atomic bomb.
Letter to President Roosevelt. In October 1938, German physicists Otto Hahn and Fritz Strassmann discovered nuclear fission, the process in which the nucleus of an atom is split, releasing a tremendous amount of energy. Fearing that Nazi Germany might develop atomic weapons, Hungarian physicist Leo Szilard, who had emigrated to the United States, sought the help of Einstein, who was a well-known figure, to raise awareness about the potential dangers of atomic weapons. The Einstein-Szilard letter. In 1939, Szilard, with the help of economist and political scientist Alexander Sachs, drafted a letter to President Franklin D. Roosevelt, which Einstein signed. The letter emphasized the potential of nuclear fission for both peaceful and military purposes and the urgency of American action in nuclear research and weapon development. This letter played a pivotal role in initiating the U.S. government's atomic bomb project. The Manhattan Project, in response to the Einstein-Szilard letter and growing concerns about the potential development of atomic weapons by Nazi Germany, the United States initiated the Manhattan Project, a top-secret research and development program to build an atomic bomb. Einstein was not directly involved in the Manhattan Project, as he lacked the necessary security clearance and was not a participant in the practical aspects of weapon development.
Advocacy for peace. During and after World War II, Einstein became an outspoken advocate for nuclear disarmament and world peace.
He was concerned about the devastating power of atomic weapons and the potential for a nuclear arms race.
In 1946, he co-authored the Russell-Einstein Manifesto, which called for international cooperation to prevent nuclear war.
Aftermath. Despite his initial involvement in alerting the U.S. government to the potential of nuclear weapons, Einstein became a strong advocate for disarmament and peaceful uses of atomic energy. He recognized the grave implications of the destructive power of atomic weapons and used his influence to promote the idea of a world without nuclear conflict.
Einstein's letter to President Roosevelt was instrumental in bringing the potential of nuclear weapons to the attention of the U.S. government, leading to the development of the atomic bomb.
However, his later advocacy for peace and nuclear disarmament reflected his growing concern about the consequences of nuclear warfare.
Albert Einstein's later life was marked by his continued involvement in various scientific, humanitarian, and political endeavors.
Despite his status as one of the most famous scientists in the world, he remained active in advocating for a range of social and political causes.
Here is an overview of his later life and advocacy. Humanitarian causes. In the post-World War II period, Einstein was deeply concerned about the state of the world and the potential for nuclear conflict. He became a strong advocate for peace and global disarmament.
He used his fame and influence to raise awareness about the dangers of nuclear weapons and to promote international cooperation.
Russell-Einstein Manifesto. In 1955, Einstein co-authored the Russell-Einstein Manifesto with philosopher Bertrand Russell.
This document called for nuclear disarmament and an end to nuclear testing. It was a significant step in the campaign for nuclear disarmament and was signed by prominent intellectuals and scientists.
Civil rights. Einstein was an advocate for civil rights in the United States.
He was a member of the NAACP, National Association for the Advancement of Colored People, and spoke out against racial segregation and discrimination. He was a vocal supporter of the civil rights movement and worked with figures like W.E.B. Du Bois to advance racial equality.
Academic and research work. Even in his later years, Einstein continued to work on scientific research and writing.
He was a professor at the Institute for Advanced Study in Princeton, New Jersey. While he did not make groundbreaking scientific discoveries in his later life, he remained intellectually engaged. Refusal of public honors. Einstein declined several prestigious honors and public roles, including the presidency of Israel in 1952. He believed that his expertise was in the realm of science and that he was not suited for political or ceremonial positions.
Legacy. Albert Einstein passed away on April 18, 1955.
His contributions to science, particularly his work on the theory of relativity, continued to have a profound impact on the field of physics. He is also remembered for his activism in support of peace, civil rights, and humanitarian causes. Albert Einstein's later life was characterized by a commitment to using his public platform and intellectual influence to address pressing global issues. His advocacy for peace, nuclear disarmament, and civil rights left a lasting legacy beyond his scientific contributions. Albert Einstein passed away on April 18, 1955, in Princeton, New Jersey, USA. He died of an abdominal aortic aneurysm, which is a condition where the large blood vessel that carries blood from the heart to the rest of the body becomes weakened and expands. It is a life-threatening condition, and Einstein's death marked the end of a remarkable life filled with groundbreaking scientific achievements and advocacy for various humanitarian causes. Albert Einstein's work in theoretical physics, particularly his development of the theory of relativity, continues to influence the field of physics and our understanding of the universe. He remains one of the most iconic and influential scientists in history. His passing marked the loss of a brilliant mind and a tireless advocate for peace, civil rights, and social justice. Albert Einstein's work had a profound impact on the field of physics and our understanding of the universe. His name is synonymous with genius, and he is widely regarded as one of the most influential scientists of the 20th century.